This is the episode 12 on the topic of integration and series. Our first problem is taken from Putnam mathematical competition. The problem says an equal to summation over k from 1 to n minus 1 sin 2k minus 1 pi divided by 2n whole divided by cos square k minus 1 pi divided by 2n cos square k pi divided by 2n limit n tends to infinity n by n cube equal to what? This is our first problem. If you want to try yourself, please do pause the video here. Follow and join with us in the Facebook page, Instagram and Twitter, Chop and Solve. Our first hint is that we have to write the term UK. Let's say UK equal to sin 2k minus 1 pi divided by 2n cos square k minus 1 pi by 2n cos square k pi by 2n. And our target is to write UK equal to vk minus 1 format, so that if you sum over UK, then it becomes the first term and the last term of the VK series. After summation you will get. So the summation will be very easy to solve. For that reason, we have multiplied 4 sin pi by 2n in the denominator and numerator, and in the numerator we have used the formula cos c minus cos d equal to 2 sin c plus d divided by 2 into sin d minus c divided by 2. So using that formula, we have written 2 into cos k minus 1 pi by n minus cos k pi by n divided by sin pi by 2n, and we have written 2 cos square k minus 1 by 2n as 1 plus cos k minus 1 pi by n, and 2 cos square k pi by 2n we can write 1 plus cos k pi by n. So moreover, in the numerator we can write that 1 plus cos k minus 1 pi by n minus 1 minus cos k pi by n, and that it becomes 2 by sin pi by 2n into 1 divided by 1 plus cos k pi by n minus 1 divided by 1 plus cos k minus 1 pi by n. You will observe that we have solved as Vk minus 1, where Vk is 2 by sin pi by 2n into 1 plus cos k pi by n. It is our first hint, and our second hint is that limit theta tends to 0 sin theta by theta equal to 1. Now n becomes, using the first hint, 2 divided by sin pi by 2n into 1 divided by 1 minus cos pi by n minus half, and we have to use 1 minus cos pi by n equal to 2 sin square pi by 2n, and we can write that 1 divided by sin pi by 2n into 1 divided by sin square pi by 2n minus 1. And if you write that limit n tends to infinity n by n cube, then it is becomes then limit n tends to infinity 1 divided by n cube into sin cube pi by 2n minus n cube sin pi by 2n. The first term becomes 8 by pi cube. You can prove this very easily if you substitute pi by 2n by theta, and limit theta tends to 0. From that you will get the first term becomes 8 by pi cube and the second term becomes 0. So net result is that 8 by pi cube. So our next problem is limit n tends to infinity 1 by n ln 2n factorial divided by n factorial into n to the power n. So we can write that 2n factorial divided by n factorial into n to the power n equal to n plus 1 divided by n into n plus 2 divided by n dot 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 n plus n divided by n. And in simple form we can write product of all k starts from k equal to 1 to n, where terms are 1 plus k by n. And if you put the ln, then it becomes limit n tends to infinity 1 by n ln 2n factorial divided by n factorial into n to the power n equal to limit n tends to infinity 1 by n summation over k equal to 1 up to k equal to n ln 1 plus k by n. We have used the formula that ln ab equal to ln a plus ln b, where ab is greater than 0. And from the definition of the definite integration, we can write that integration from 0 to 1 ln 1 plus x dx. And if you substitute 1 plus x by x, the limit changes, 0 changes, that the lower limit becomes 1, the upper limit becomes 2. Integration 1 to 2 ln x dx. If you integrate ln x, then you will get x ln x minus x. If you put upper limit and lower limit, then you will get 2 ln 2 minus 1. Thanks for 900 plus subscribers. Stay healthy, stay safe, stay tuned, and keep watching. If you have any doubts or if you want to send us some problems, then fill out the Google Forms which is in the description, and feel free to discuss what do you feel about this series or about or some kind of suggestion, good or bad. You may write down in the description box, in the comment box. Thank you.